A very good morning team, this is Amir Mustafa. In this video we will understand Docker volumes and what problem Docker volume fixes, which we have seen, the issue which is fixed. We will also see anonymous volume. Before going into this video, let's quickly have overview of the previous one. So in the previous video what we did was we had a Node.js application. We just dockerized the application, so instead of opening from package.json file, we were creating the image, dockerizing it from the container, we are running it. So we need not see depth for now, but what is important is once our application is running, we have a feedback form where user comes, enter his data and saves it. So the logic in which it was written is that if a user enters a title and heading, this title becomes, for this the logic was written in this way, the title becomes the file name and this feedback is saved in a file. If file exists, it is saved in one place. If does not exist, save in one place, and if it is existing, we say user to please re-enter the feedback. This is already saved. For today's video, let's understand Docker volumes. Before, let us understand the problem which Docker volume fixes. What is the problem which we got in the previous video? So the problem is that once this application is here, server is running, be it in any technology, once the web application is running, we get a form, and whenever a file is saved, it is saved inside a container. Suppose we write first feedback awesome, this is awesome feedback, okay. Second feedback we write cool, this is cool. So second feedback goes, one is awesome.txt, second is cool.txt, and it is stored in the inside the container. So if we see over here, just one quick thing. So once this is saved, when we go to this file, we get the file. So file is accessible over here because we have created the feedback and container. True. But the problem is this: once we delete the container, suppose we create the container with RMI flag. What it does, it deletes the container once we finish it. Means suppose the Docker container is stopped. So once we delete the container, the files with it is also lost. So suppose we are in a this is a dummy application that we are seeing feedback. Suppose we are using one application which is using product data. It is a real-time e-commerce site and user have entered lots of products. Now suppose there is a code modification required and we rebuilt the image and recreated the container. So in that point of time, what will happen, that all the previous product which user have created will be lost. So this is the issue. So until when container exists, in that point of time, all the file exist. Once we delete the container, and this is obvious, that file with it also gets lost. And this is a real-time scenario. This will happen quite often, because whenever we develop an application, most of the time it is required that we do some modification, recreate the image and container. This will this will lose the file. So in today's video we will understand Docker volumes. Now that we understand the problem, so what solution does Docker volume gives? So Docker volume helps in persisting data. So Docker has a built-in feature called volumes. Like we have in a computer, hard drive is a volume. We keep some space data over their file here or external hard drive. So whatever we have stored till now, we were storing inside the Docker container, and container was deleted, file was lost, and it is accessible. Now Docker volume concept, how it runs, if you see from this image, so there will be two paths. One path is stored somewhere in our computer host machine, and one path is the Docker path where file exists. So what happened, both will be mapped with each other. If we add a file to the host machine, our system, it is accessible from container or inside the container, and the vice versa is also true, that any change over here is also accessible from the hard drive computer. So volume persists data even if a container shut down. Suppose there are 10 containers and most of them got stopped. Now all the previous containers file is also linked with the new container, so our data will not be get lost. So let us dockerize the application using volumes. So in this video we will first implement the first type of volume. It is called anonymous volume. So let us dockerize the application now. How will Docker understand that okay, we need some volume? For that we use Docker file. We write instruction over here. App feedback. So this is the first type of volume. It is called anonymous volume because here we write only one path, and this path is the Docker path itself. So what Docker does is that it automatically chooses somewhere in the machine, our system, where to map, and we are not supposed to know it because Docker manages it by itself. So the first step we write is Docker volume. We write volume instruction. Okay, so we will follow along with this document. This one we need, let's understand the code, how it was working. That we have a temp path, we have a final path. Suppose feedback was coming. So how the logic is written, that first file gets stored in a temp path. If file exists in this path, app/feedback, we say please re-enter. We tell user to please re-enter the feedback with a new name. And if it does not exist, we save it. Okay, now we'll follow our steps. So the first step is we have introduced volume instruction in Docker file. Now we will build the image. You can also parallelly see this instruction. So first one is Docker image name followed by tag. Docker build -t, and let's go over here. Feedback node volumes. We are working with volumes, so we are writing volumes over here, and dot. So we could have written without this, but what it does, it has generated random ID. So we have assigned name to our image, which is called feedback node : volumes. we need to make sure that our Docker is running from here. Otherwise this command, what it will tell, Docker is not recognized. This will take less time, a couple of seconds. Alright, so we see that our image is created over here. We have a SHA ID, and visually we can see from here. See, inside the image section now we have our this was not there earlier, and if we go over here, open this image, let me refresh it. So what will come, that this volume is created. I've created some time back also, but it takes time to refresh. So here our volume is created. We can see that our ID is generated over here. Okay, so what is the first step what we did? Creating the image. We have created the image with volume instruction. Let us go back to the instruction. The next step is that we need to create a container, and for creating the container we'll follow this instruction: docker run d. This is the port in which we want to run in the browser. Suppose 3080 is the port. Docker -rm. So what rm does it, this is the thing which we were talking about. When we create a container using rm flag, when we stop it, we'll stop it soon, for re-entering the new, for deleting the container, recreating it. So this container will be deleted automatically. So let us write command docker run d. D means detach mode. It means when we'll put enter, at that time we can write more commands and it is not stuck in the one loop. Port 3080. This is mainly the Docker port. This is the port will run in the browser. Then our volume name, image name, sorry, back node volumes. This is the image name, and now we are assigning name to our container name. Let us call this feedback app. Do not worry about the syntax, just go through this one once. Here we write browser port, docker port, rm name, container name, we write the name which we want to assign to the container we are about to create, and the docker image which we have created just some time back, which is this one, docker volume. Okay, now we see that we have no container active over here, so we are about to create a container. Let me do one thing, close this terminal and reopen it. One second. Need to remove or rename. Feedback is already in use. Okay, alright. So it was created and we missed it because we were highlighting it. It was created. So how we will understand that our container is running? We see that this is playing from here and a container is creating. It was highlighted, so missed this one. So container was created, which we did. Docker volume. So we can see from here, if we expand a bit more, we'll see that feedback app is here. We can see details. Now let us open our application. Localhost 3000. Okay, we have zoomed a bit. Let me unzoom it. Okay, we can write any text here. This is from container 1. So what we are doing now is we have entered one feedback, we have submitted it. Why it is taking time? Okay, so once data is submitted, we go to feedback. See, what we are trying to do, that this path which is having is accessible. We are entering this path and we can see there's a data is here. What we are trying to understand here, we are trying to understand that we have created, now this is the container which we have, and here we have added multiple. This is just a feedback for now, but this can be a data, product data, user data. Now for some reason they think that there are thousands of this record over here because our application was deployed. Now a new feature came. Now once the new feature came, so for any change in the code, we need to create the image again, container again, and re-edit. And that point of time, all the previous file will be lost. Let's go and see whether we can access it using anonymous volumes or not. So the first time what we'll do, we'll follow this one only. Okay, so our next period will follow this command docker stop container name. We'll also see that it will be deleted from rm flag the container delete from it.